In this video, we're going to take a look at how we can use Excel to create the PDF and CDF values for a negative binomial random variable. Now, unlike the binomial random variable, the sample space for the negative binomial is countably infinite. So we can't possibly list all the values in our sample space. So this will just illustrate how you would do it in general based on what a question is asking or what values you need. Then we will utilize those values, right? Another thing about Excel is, as far as the negative binomial distribution is concerned, you have to specify not just the number of successes, but also the number of failures, right? So the number of failures, that is what we don't know. Maybe there are no failures and we get the number of successes right in our first set of trials, but we could end up having one failure, two failures, or so forth. So we'll talk about how to set that up in a second. In this case, we're going to use the negative binomial with an R of 5 and a P of 0.2. So we're going to see probabilities that are associated with getting the number of trials until the 5th success. And each success has a probability of 0.42 occurring, right? Okay, so first the number of failures. So that's what we don't know. And again, this is where it depends on what the question is asking. So I'm just going to generate a sequence, let's say going from 0 to, let's say 10 values in this column, right? So the sequence function will do the trick for us. So I'm going to put an equal sign, and then the function is sequence, open parentheses, how many rows? Like I said, let's do 10, right? How many columns? Well, everything's going to be in column A. Where does it start? Well, it's possible that we have 0 failures, right? And then what's the step? Well, again, the possible values are consecutive integers. So put a 1 there. That's basically your delta, the gap, the size of the gap between our possible values of x. Close parentheses, hit enter, and there we go. So there are the 10 possible values, 0 through 9. Now, the number of successes in a negative binomial distribution is fixed. So we want all of these to be 5, right? So the number of successes is fixed at 5. So the way you can use the same sequence function, it's kind of a nice little trick. So let's do equals sequence, open parentheses, same thing, 10, one column starting at 0, but and now let's see. Oh, actually, starting at 5, that's what we want, because they're all 5. And then what we want is we want our step size to be 0. So if we want a constant sequence, then we put our step size at 0. And then close the parentheses. There we go. And that's it. So again, it's the way the negative binomial function is defined in Excel, why we need to specify these two values. So what actually is happening here, the way we do it by hand, we define the random variable as the sum of these two, right? So it's the number of trials up to and including the 5th success. So if there are no failures, then the sum of the number of failures and the number of successes would be 5. So that's why our sample space, when we do these by hand, they start at 5. And then the next possible value will be this sum, which would be 6 and 7 and so forth. But to define this in Excel, we need to specify these values as well as these values, right? And it's these values that would vary. So depending on what the question is asking, you could just generate a fair range of values and then set your number of successes to be that constant value of R. And now once we have these two, then we can find our PDF and CDF values. So I'm going to click on the cell that corresponds to, again, this initial value of 0. And again, these are all 5. So click on that cell, and then up in the formula bar, The function for the negative binomial distribution in Excel, it's neg binom and then period dist, and then open your parentheses, and you know you have it right when it then tells you all the things that you need to put in. So notice first the number F, that's the number of failures. So we have those in column A, going from A3 to A12. So I'm going to type that range in. So A3 colon A12, and notice it selects it for us. Perfect. Next up, it wants the number of successes. Well, those are in B3 to B12. So B3 range to B12. There we go. What's our probability of success? Well, that's our 0.42, so 0.42. And for this one, for the PDF, we want the cumulative to be false, right? Because I want the exact probabilities. So I put a 0 there for false, close the parentheses, everything looks good, hit enter, and there are our probabilities, right? So for instance, the way we would sort of interpret this, and I'll type this down here. So let's say we wanted the probability that it will take exactly 11 trials to get that first success. That would be this, right? Because this would include the possibility of getting 6 failures and our 5 successes for a total of 11 trials. So that probability here, let me just kind of paste it down there. And oh, can I not paste? There we go. Right. So the probability that our random variable is equal to 11, right? The number of trials to get that to up to and including that 5th success is 0.104480131, right? So again, it's just the way how Excel defines their probability distribution, why we have to specify these separately, right? Now, if we want the CDF values, right? So if we want Excel to go ahead and accumulate these, right? And it makes sense. And so in terms of the cumulative ones, it makes sense to start at 0, right? Because that will be the smallest possible number of failures you can observe, and then you do these consecutively. So that's why it's good to do like a consecutive range of values here. That way, when you do the CDF, it will add up all those corresponding probabilities, right? So let's make sure that we've clicked on the cell, that first cell for our CDF values. Go up to our formula bar, equals, and then it's the neg binom period dis distribution, open parentheses. It's the same thing. Number of failures are in A3 to A12. Number of successes are in B3 to B12. And probability of success on any given trial, that's for 0.42. And then now we want the cumulative to be true. So we want Excel to go through and accumulate all these probabilities. Now, this one is not going to end at 1 because we've only listed up just a few of the possible values of X, right? But let's see how close it is. Okay, not too bad. But there we go. So these are our cumulative probabilities now. So let's say we wanted, like the question asks us, what is the probability that our random variable is less than or equal to, let's say, 9, right? So that means we will take at most 9 trials to observe the 5 successes. Well, we would have to look at this row, right? Because that's the row that has the 4 failures and the 5 successes, and that cumulative probability is this. So see if I can copy there, paste that in, and there we go, right? So With the negative binomial, it's a slightly different way that it's handled in Excel, but it is consistent with how we do it by hand. It's just that in Excel you have to kind of break out these two things, which is a little strange given the fact that this is a constant. You would think, they could just keep track of this, and once you tell them how many successes you're looking for, they could go ahead and just incorporate it. But the way the function is currently built, you have to specify the number of failures, which is what we don't know, and the number of successes, which is our constant r, right? So that's the negative binomial in Excel. Try it out, have some fun. Let me know if you have any questions. See you in the next video.